My name is Parker Lusk, and today I'm going to be talking about the health and safety concerns of 3D printing. 3D printing is one of the fastest new emerging technologies that's on the market today. It traces its roots back to the 1980s with a device called the stereolithography apparatus, shown here in this patent, which was invented by Charles Hall. Since the invention of the SLA, there have been a lot of different improvements to 3D printing technology. Some of the most common types used today are stereolithography, fused deposition modeling, selective laser melting, and digital light processing. Among these, arguably the most commonly used and most well-known is fused deposition modeling. Fused deposition modeling, also called FDM, works by taking a filament, which is essentially like a polymer thread, and melting it down through an extruder head and then layering it one after the other to build a three-dimensional structure. With FDM, you can make things now that previously you were unable to make with traditional methods. So you can make things like this buckyball, which is a geometric shape that has concentric shapes inside of it, or even a 3D printed biodegradable stent that can be used in an artery. Now, since FDM and 3D printing's explosion onto the consumer market, there have been a lot of health and safety things that have been unable to catch up and keep pace. So more research needs to be done into this. One of the first things that comes to light when talking about FDM and 3D printing is ultrafine particle emission. So ultrafine particles are extremely small molecules and like dust that come off of the 3D printed objects. One of the most common filaments used in 3D printing with FDM is called acrylonitrile butadiene styrene, or ABS for short. ABS is used for a lot of different reasons, but mostly because it's cheap and it's a thermoplastic. Thermoplastic means you can take the solid ABS, heat it up, and turn it into a liquid, and then as it cools back down to room temperature, it goes back to solid. And this process can be done over and over again without any significant loss of strength. But with that heating and reheating and deposition comes the possibility to emit ultrafine particles into the air. Now these ultrafine particles can affect how humans are. They can cause asthmatic symptoms. They can even possibly cause strokes. Secondly, the heating of these thermoplastics can cause fumes to be released into the air. For example, ABS that we previously mentioned, when heated, produces styrene. Styrene is known to be a carcinogen and toxic. So, because of these first two issues, whenever you're using a 3D printer, you always have to be conscious of how you're using it and what your environment is. I mean, you can imagine being stuck in a small room with no ventilation. You're basically breathing in toxins and these dangerous ultrafine particles. Finally, 3D printing can take a massive amount of energy. Loberg University showed that 3D printers can use 5 to 50 more times electrical energy than traditional injection molding to make a part of the same size and weight. So, in conclusion, 3D printing is an amazing new technology. It's cheap, it's innovative, but there needs to be more research done. We need to look out for how these things affect us so that we can know whether there are any potential dangers. And more importantly, we need to know how these things and how these technologies will affect generations to come after us. Thank you.